Alright, geometry, let's get going today on lesson 7. But before we do, as always, make sure you guys like the video, subscribe to the channel, and hit that notification bell so you guys can see these videos as soon as they come out. Now let's jump into this. Lesson 7, general pyramids and cones and their cross sections. As remember before, cross sections are these planes and these shapes that are parallel to the top or the bottom. Now, let's sort these. Let's make some that look alike. I'm gonna go 1 and 6 look alike. I'm gonna say 2 and 7 look alike, and I'm gonna say all the rest of these look pretty much alike. I mean, you could make the case that 3 and 8 look different, but this is just me, guys. This is how I would group it, just because, in 1 and 2, we have these full prisms, or cylinders, sorry. We have these full cylinders, and they're both really odd shaped. And then in 2 and 4, we have these prisms, and then with the rest of them, we have pyramid or cone shaped things. Now, a rectangular pyramid. Given a rectangular base in a plane and a point not on that plane, a rectangular pyramid is the collection of all segments from any point of P and B. So all that means is that a rectangular pyramid looks something like this or like this, and a general cone looks something like 8 or 3. Now, this is showing you guys how to draw them and what the differences are. Figure 1 and 2, this is a cone. Down here, this is a pyramid. Okay? Again, pyramid, cone. So in example 1, let's look at this. In the following triangular pyramid, a plane passes through the pyramid so that it's parallel to the base and results in cross-section A', B', C'. If the area of ABC is 25 millimeters squared, what's the area of A', B', C'? Now, guys, this should look really familiar. This is just like scale factors. So whatever this side is here, this is going to be, 3/5 of it. And how do I know it's 3/5? Well, because we're going from 5, so 5 units away, to 3 units away. So we're dialing it back. And if you guys want a better example of something, we could take another one right up here that is 1 unit away. So in order to get it from 5 down to 1, we have to divide by 5, and then to get it from 1 to 3, we need to multiply by 3. So it's 3/5 for our scale factor. Now, if our scale factor of the sides is 3/5, then our scale factor for the area is going to be 3/5 squared, which is going to give us 9/25. Now, the reason it's squared is because we're doing it to each of the sides. So we're doing it to each dimension that we're multiplying together. So what we're doing here is we're saying that, we have a base times a height for our area, right, guys? In order to find the area of a triangle, it's base times height. Well, what we're doing here is we're taking 3/5 of that base and multiplying it by 3/5 of that height, and then dividing by 2, which is going to give us 9/25 of the base times the height divided by 2. So it's 9/25 of that original area. And what is that original area, guys? If we look, after I erase all of this stuff, so if we look, the original area is 25. So 9/25 of 25, well, that's just going to get us 9. So our area for this triangle right here for A', B', C' is 9 square millimeters, or 9 millimeters squared. Now, I went through that super fast, I know. I'm going to do another one right down here with exercise 2. So this one's a little bit different here, guys. What this is saying is that the distance from this triangle, A', B', C' to V is 12, and the distance from ABC to V is 18. So what's our scale factor? Well, let's first figure out where we're trying to go. We're trying to go from A', B', C' to ABC. So we're going to divide by 12 to get to 1 unit away, and then multiply by 18. So it's 18/12, which is 3/2. Now, again, we're going to have to square this because we're doing this to each dimension. So if we square this, it's 9/4, and we're going to take 9/4 of this 28 millimeters squared, which is going to get us 9 times 7, which is 63 millimeters squared. So that's the area of ABC. Now, if you guys need a recap of that, go ahead and just rewind the video, look back, pause it, do some of these on your own, try and make up your own ones, whatever you guys need to do to get this in your heads. Or just write down the notes and use those on the quiz. Perfectly fine by me. So here's an extension. So what this is saying is that this is going to work. We showed it for the pyramid, but this will work for any cone or anything like this when we're trying to figure out these shapes. And we will get a theorem here soon, guys. Don't worry about that. Theorems are amazing, and especially when it comes to this. So the area of the base of a cone is 16. So I'm just going to draw a little oval. And here's my cone. Actually, I want to use. So there's my cone. And the height is 10. So this whole height here is 10 units. Find the area of a cross-section that is distance 5 from the vertex. So we're going to come up here, draw another oval, and this distance right here is 5. So what's our scale factor? Going from the base up, well, we need to divide by 10. So we're dividing by 10, and we're multiplying that by 5. And then, remember, guys, we need to square this. So that's 25 100ths. And now we need to multiply this by 16. We're taking 25 100ths of 16. Now, some of you guys may be like, I don't want to multiply that. What is 25 100ths? 25 divided by 100 is just 1/4. So we're taking 1/4 of, I don't know why I put a 2 there. 1/4 of 16, which 16 divided by 4 gets us 4. So our area of this smaller cross-section up here is just going to be 4. General cone cross-section theorem. This is a great theorem, guys. One of my absolute favorites when it comes to geometry. If two general cones have the same base area and the same height, then cross-sections for those cones at the same distance from the vertex have the same area. So all that's saying is that if the area of B is equal to the area of C, then the area of B prime is equal to the area of C prime, if these two have the same height of H. And this, and we'll call it G, is exactly the same. And don't worry about proving it, guys. Just do what you guys need to do. That's okay. Exercise 2. So the following pyramids have equal altitudes, and both bases are equal in area and coplanar. Coplanar just means that they exist on the same plane, meaning they're exactly where they are. They're on one single plane. So if I were to draw a plane like this shape sits on this. So it's like saying, you know, I have my phone and my computer sitting on my desk right now, so my phone and my computer are coplanar. And both pyramids cross-sections are coplanar. So, like, if I were to, put a little, I don't know, if I were to put a little shelf on my desk, don't know why I would do that, but if I were to put a shelf on my desk, then I put something on that shelf, those two things are coplanar as well. So if BC is 3 square root 2, and B prime C prime is 2 square root 3, and the area of TUVWXYZ is 30 units squared, so this area right here is 30 units squared. What's the area of ABCD? Well, what we're going to have to do is we're going to have to figure out what our scale factor is going from here up to here. So what do we have to do first? Well, we need to divide by 3 root 2. And then that will get us up here where we're 1 unit away. And then we need to multiply it by 2 root 3 to get down to this cross-section. So doing that, what is 2 root 3 divided by 3 root 2? I want to say it's like 8.4 something. Or sorry, 0.84 something. So 3 times 2 square root is 4.2426. And 2 times the square root of 3 is 3.4641. So if we divide these, so 3.4641 divided by 4.2426 gets us 0.8165. So this is our scale factor going from here up to here. Now remember, guys, we need to square this square factor. So squaring this, we get 0.6666, 0.667 if you round up. And now we take this and we multiply by 30. And that gets us 20. So the area of these two sections is 20. And now how do I know that these bases were the same? Well, they're coplanar and they have the same height. So that has to be a 30 as well. That's by this general cone cross-section theorem. Now, they wouldn't have put this question in here if the two bases were different, so I assume that the two bases are exactly the same, which they should be. And so, if you guys want to look at it, what that theorem is really saying is that because these are both 30 and they have the same height, if this is 20 units squared, then this up here is also 20 units squared. So, lesson summary, a cone. We have more definitions for you guys. A cone, a rectangular pyramid, and a lateral edge and face of a pyramid. Alright, so the base of a pyramid has an area of 4, and the cross-section that lies parallel in a parallel plane that is distance 2 from the base of the plane has an area of 1. So we need to find the height of this pyramid. So first, let's find our scale factor. So if we're going from, this bigger shape down here to this smaller shape, what we're going to do is we're going to say that our scale factor squared times 4 is equal to 1. Well, that means that our r squared is equal to 1/4, which means that r has to be 1/2. And so what we're going to do here is we're going to call this h prime. So then what we're going to say is that h prime is equal to our total height minus 2. So then let's set this equal to our scale factor. So then h minus 2 divided by h is going to be equal to 1/2. Well, multiply both sides by h, we're going to get h minus 2 equals h over 2. Multiply both sides by 2, you get 2h minus 2 equals h. Add 2 to both sides, subtract h, you get h equals 2. And I forgot that should be h prime. So then our total height is going to be equal to 4. Alright, guys. I'll do one more with you guys. Let's look at number 8. A rectangular cone and a triangular cone have bases with the same area. Explain why the cross sections for the cones halfway between the base and the vertex have the same area. So this comes down to that theorem we were talking about. So because they have the same height, we know that this is going to be, we'll call this x, and we'll call this x. So what we're going to do is we're going to divide both sides by x so we can get, or by our height. Jeez. Because these both have the same height. We're going to divide this by height to get us to a 1 unit away from the vertex. And then we're going to multiply by this new height. We'll call that h prime. And again, it's going to be the same as over here. They have the exact same height. And this h prime is going to be exactly the same. So if we take x and we divide by h and then multiply by h prime, no matter what x is, it's going to be the same thing because we're doing the same things to each one with the exact same numbers. All right, guys, so hope this helped out a lot. If you guys need to rewatch this video, as always, make sure you guys like, subscribe, and hit that notification bell so you can watch these videos as soon as they come out. As always, guys, enjoy this math and have a great rest of the day.